My name is Jimmy Costello from the NX product marketing team, and I would like to discuss with you how NX can significantly improve your design productivity. In the graphics window, you can see a joystick assembly from a mechanical excavator designed in NX. I'm going to isolate one of the components so we can add further design features to it. My first task is to stiffen the plastic component, and to do that, I will add a network of ribs. Now I can design these from scratch, but I know that the reuse library has some pre-configured 2D rib networks that I can use, which will speed up my design process. To position the ribs, I will use a datum plane that is already in the part, and once I show it, I access the reuse library and select the rib network I want and simply drag it onto the plane and then reposition it relative to an existing boss. Now that I have my rib profile in position, I can use it to create a rib feature. Notice that as I have only one solid body, the target for the ribs is automatically selected. All I need to do is select the profile and define the thickness and then the draft value if needed. Notice the preview of the result, and also notice that the solid ribs automatically extend to find closure with the target body. You can also make adjustments to any value if necessary before completing the command. As previously mentioned, the ribs automatically extend, but what if I want the ribs to extend past the bosses? Well, as the rib network is a sketch, we simply make changes to the sketch and the part updates to reflect the modified profile. Zooming out once again, you can see that the ribbing in the part now reflects these changes. To complete the rib design, we will add some blends. We can use some of the smart selection methods in NX to quickly select multiple edges simultaneously. You will also notice that NX has artificial intelligence-based selection, where after selection, one edge, NX automatically predicts and highlights other similar edges you may want to include. Again, this significantly improves productivity. As you can see, the edge blends have now been completed, softening the corners of the intersecting faces of the rib body. I have one more design modification to complete. This component needs to have clearance between it and another component in the product assembly, and we have a reference body that we can use to define it. We will use this sheet body to create an emboss feature. Now you can see that the emboss body has been completed. The next thing we will do with the part is go ahead and apply some edge blends to the new feature. To do this, we will use the Feature Intersection Edges Smart Selection tool and quickly grab all the new edges. This tool selects all the edges of a feature with one simple click. Hitting apply, these blends are now already completed. Now that these blends have been finished, the last thing we want to do is look at a section view of the part to make sure every feature has shown up as expected. By looking at a section view, it is much easier to get an understanding of how the product will actually function. Zooming in on the counterbore hole, it is apparent that the embossed body changed the initial hole depth. To fix this, we can open up the part navigator and scroll down to this counterbore hole. As you can see, the hole is located above the emboss. By dragging it below the emboss, the hole now cuts through the emboss as well. So just to recap what you have seen, we isolated a component in the assembly, and then using the reuse library and rib feature, we very quickly added stiffness to the part. We then removed some sharp edges on the ribs using both intelligent selection criteria and AI-driven selection prediction to create some edge blends. Finally, we added an emboss for clearance, and again utilized intelligent selection to apply edge blends. I would like to thank you for your time and attention.